Hello, I'm Thomas, and today I explain the technical details of Immich, a popular self-hosted open-source photo and video management application. This video covers these topics. First, what is Immich? Then I will discuss the architecture, followed by the backend API server, the ML microservice, the web and mobile clients, and finally deployment and the documentation side. I will start with a short introduction of the Immich application. If you use Google Photos or Apple Photos, you will find Immich familiar. It is a self-hosted photo and video management solution. Immich is fully open source and allows you to view, modify and install its source code on your own machines. Immich provides a web interface, mobile apps for iOS and Android, and a command line interface. Immich also offers AI features such as facial recognition and advanced search. Because this video focuses on a technical overview, I will next discuss Immich's architecture. A top-level diagram displays Immich's three access methods: the web front-end, iOS and Android mobile apps, and a CLI tool for administration. Below these interfaces lies the backend featuring the Immich server built with Nest. The backend stores data in a PostgreSQL database, schedules background jobs, including video transcoding via BullMQ, and relies on a Valkey Redis key value store. A Python-based machine learning microservice performs inference, handling facial recognition, OCR, and smart search. The backend and front-end communicate through an open API specification generated from Nest annotations, and the front-ends use SDKs derived from this specification. The API server sits at the core of Immich's service architecture, accepting front-end requests, persisting data to PostgreSQL, and scheduling worker jobs. Its core components belong to a Node application written in TypeScript with Nest, which emphasizes modularity and proven patterns for building well-architectured servers. Immich's servers uses Kaisali to build type-safe SQL queries in TypeScript, and it stores data in PostgreSQL. VTest performs unit testing, while ESLint enforces coding standards. Video transcoding runs with ffmpeg, and the service extracts image metadata with ExifTool. An open API specification generated from NestJS decorators creates SDKs for both web and mobile clients. The source code resides in a monorepo that consolidates all components. The API server resides in the server folder, following Nest conventions with directories such as commands, controllers, and DTOs, and a package.json lists project dependencies. The server also communicates with the ML service. The ML service runs independently and can run on a separate machine. Because it performs AI inference, we recommend a GPU-equipped computer, such as one with an NVIDIA card. The microservice is written in Python with fast API. It offers AI analysis tasks, including face recognition, object detection, and smart search, and runs intensive operations in the background. Face recognition uses inside face models. ONNX powers model inference, and the service performs OCR using rapid OCR. The Python source code is located in the machine learning folder. Next, I discuss the web application for managing Immich photos and videos. The web client is built with TypeScript and SvelteKit, utilizes Tailwind CSS and bundles with Vite. VTest performs testing, while Svelte I18N enables multilingual support. MapLibre supplies mapping functionality, and the web interface's source code resides under Web. In addition to the web frontend, there are mobile frontends. Mobile apps for iOS and Android are developed with Dart and Flutter. They use either for local database storage, and Riverpod manages application state. The source code resides in the mobile folder and includes native code for each platform. The backend must be deployed on a server, which I will discuss next. The backend, including the API server, ML microservice, PostgreSQL database, Valkey store, and BullMQ queue, is deployed with Docker Compose. Optionally, Prometheus and Grafana monitor production deployments. Docker Compose files illustrate the setup. Before concluding, I discuss the documentation website. Immich documentation is generated with Docusaurus, which uses React and Tailwind. The content appears in Markdown and occasionally MDX, and it is currently available only in English. We have reached the end of this video. Thank you for watching, and please subscribe and like it if you wish to support the channel.